Homework 1.5, Quadratic Equations, Video 7. Homework due Saturday, May 16th, 2020 at 11:59 p.m. Alright, so I think it's about time we get to the big part of this homework section. And that's how to solve a generic quadratic equation. Because what I've given you so far are techniques. If it's factorable and you're capable of factoring it, do this. If it's only got one x term, do that. If you can't do either, then do something called completing the square. So it would be nice if we could take a generic quadratic equation, one of the form ax squared plus bx plus c is equal to 0, with the stipulation that a is not equal to 0, because if it was, then it wouldn't be a quadratic equation anymore. It would be called a linear equation. But it would be nice if we just had a formula that said, just tell me the numbers and I'll spit out an answer for you. And a formula exists, and you may already know it, but I'm not going to show it to you yet. I will go ahead and tell you that what you're about to see is not something that you're going to be held accountable for, or at least not the process with the end result. And you could actually skip this video, go to the next one, and be okay. This is because I don't like leaving loose ends. So we're going to build a technique for solving any equation based on the 3 numbers in it. Now, how are we going to do that? Well, we can't factor it because we don't actually know what the numbers are, so how can we possibly try to factor it? And currently, we can't solve it using square roots because it has 2 x terms, but we fixed that in the previous 2 videos by completing the square. So we're going to attempt to solve this by completing the square. And it's going to look a little nasty in the middle, but I promise you, none of the moves that I'm going to do are that difficult to follow. They're just difficult to come up with on your own. So luckily I know how this journey goes by completing the squares. How about completing the square? All right, now I've erased the formula or the approach for completing the square, so I'll just have to verbalize it without writing it again. But the premise behind completing the square was to find the perfect number that would cause it to factor into one parentheses with a square on it. And in order to set it up, we had to do 2 things. One of them we did repeatedly, and the other one we never did at all. Number 1, we got to move this. But number 2, this has to be a 1, and it's not currently a 1. So we're going to have to fix that by dividing it away. So the first move that we're going to do, and again, you're not going to have to replicate what you're about to see, but I'd like for you to watch this. We're going to divide everything by a. Because if we do that, this will be a divided by a, which is 1. This would become b divided by a, which I can't do anything with because I don't know what those numbers are. That's the new coefficient of the x. This would become c divided by a. And of course, 0 divided by a is 0. Okay, so I got some fractions a little bit early, but it was necessary because I can't do what I'm about to do unless this number is 1. Now, we need to move the constant. Remember, the premise behind completing the square is the number that is here is probably not the one that you want. Move it. If I move it to the other side, it will become a negative. So x squared plus b over a, x, equals negative c over a. Now for the fun part. We're going to complete the square. Now, how can we possibly do that? All we have is a bunch of letters. We don't even have numbers. But remember, the premise behind completing the square was not based on the actual value there, but what you did with it. And we had a process for that. The process for completing the square was to grab this number, take half of it. So let's start with that. Half of b over a. Well, in math, the word half often means multiply. So 1/2 times b over a. And the rule for multiplying fractions is multiply across the top, multiply across the bottom. So 1 times b is b, 2 times a is 2a. But then what did we do with that value? We took half of this and then we squared it. So if we take b over 2a and square it, you can distribute the square across a fraction. Let me pause for a second. You can distribute a power across multiplication, and you can distribute a power across division. This is multiplication, this is division. I can distribute the power. The b gets squared, the 2 gets squared and becomes a 4, and the a gets squared and becomes an a squared. So what is this? This is what I have to add to both sides. As ugly as it is, it's the correct thing. So, to complete the square means that I need to add to both sides b squared over 4a squared. Not only on the left, but on the right. And because the right side already has a negative term, and I'm about to add a positive term, I think I'm going to write the positive term first. So b squared over 4a squared first, minus c over a second. It just looks cleaner to lead off with a positive if you have the option. And when you add the correct term to both sides, you're supposed to be able to factor the left into something predictable, something squared. And we don't have to guess, because in all this mishmash of letters floating around, the term that goes here is what you got after doing the half of move. Go back and watch the previous video. Whatever we got when we took half of is what showed up here, which means the term in here is going to be b over 2a. Now on the other side, we got another issue. We've got this subtraction problem involving fractions, but we know the rule for subtracting fractions: get a common denominator. This denominator has a 4a squared. This one has just an a. Well, if I give this a 4 and another a, it'll match that one. But whatever I give to the bottom, I have to give to the top. So I'm going to give the top a 4 and an a, and I'm going to give the bottom a 4 and an a by writing a squared. That gets me a common denominator of 4a squared, and on the top we just combine the numerators. So b squared minus 4ac. And some of you are having some epiphanies right now. If you don't know what epiphany is, E-P-I-P-H-A-N-Y, go look it up after this video. Or shoot, pick up your phone and ask Google what epiphany means, or ask Siri or whoever. But anyway, we can subtract these two fractions and we get this bigger mess, b squared minus 4ac all over 4a squared, and now we've got it to a point where we can solve using square roots. Because remember, you can solve using square roots when there's one x term. And with all these letters out here, there's only a single x. So if I hit both sides with a square root, we'll continue up here. It'll cancel the square. We'll get x plus b over 2a equals, we need a plus minus on the other side, and we need to square root that fraction, which looks very daunting. Look at this mess. The square root of b squared minus 4ac over 4a squared. Well, I've almost got the x by itself. All I have to do is move this over and it'll become negative. So let's go ahead and do that. Negative b over 2a plus minus, but let's look at the square root of the fraction. Not very long ago, I just said you could distribute a square across a multiplication and division. Well, the same thing goes with square roots. They can be distributed across fractions and across multiplication problems, which means I can square root both sides of this fraction separately. Now on the top, I'm stuck because there's a minus and you can't distribute a square root across a minus. So if I split this square root across the fraction, I'm stuck with the square root on the top. However, I can square root the bottom because the square root of 4 is 2, and the square root would cancel the square on the a. And just like that, we have like common denominators. So we might as well pop it all together under one denominator, over one denominator of 2a. And on the top we get negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you haven't had an epiphany by now, it means that you don't remember the quadratic formula. So, if you attempt to complete the square on a generic quadratic equation, even if you didn't follow it, the end result is what you probably remember as the quadratic formula. Again, I'm not going to ask you to replicate this process of deriving the quadratic formula, but I'm not one to just say, here's the formula and it magically works. Here's where it came from. If you want to watch it again, great, but I'll say the same thing I did at the beginning. You can skip this video, go to the next one, and you're going to be okay. Because in the next two videos, which will probably be the last two videos of this series, we're going to look at using the quadratic formula.